CEO of STEMconnector. And in my background, in my dim and distant past, I studied for a PhD in quantum physics. And for many of you, you're wondering, what is that? Well, it is the study of things that are really, really small, incredibly small. Today, I'm joined with Tessa Rundle, and Tessa is a spacesuit life support systems engineer. And Tessa deals with things that are really on the other end of the scale, very, very large. So I would like to welcome Tessa to the conversation today.
Thank you for having me. I'm excited to be here.
Now, Tessa, you got your bachelor's degree in physics and a master's degree in aerospace engineering. And now you're working at NASA, which is, I think, a place everybody listening to us today knows about NASA. Pretty exciting, I'd imagine. What ignited your passion for science?
So my passion for science actually started a bit later than I think it does for a lot of people that end up going into a career in science. So when I was growing up, I was very interested in music and theater. I was in theater production since I was a child. And I actually actively avoided math and science classes as much as I could in high school. And I definitely did not see myself having a career in science or, studying physics or engineering. But it was during my sophomore year of college. I was actually a music major when I started college. And during my sophomore year, we had to take lab science classes to fulfill general education requirements. So at this point, you could pick any science classes you wanted to take. You just had to fulfill the requirements. And I was kind of dreading it, but I did see that there was an astronomy class as an option. And my grandparents, when I was growing up, my grandparents lived on a lake and they had a telescope, and my grandpa would always show me cool things in the sky when we went to visit. So if I, had to pick any science field that I was interested in, I would have probably picked astronomy. So I took this astronomy class, and it ended up kind of opening my eyes in a lot of ways, learning about the universe, all of these facts that seem to be so far-fetched. And I had a really great professor for the class as well that kind of made me see science and math in a new light. So after the semester, I decided to see if this professor, who I thought was really great, was teaching any other lab science classes to fulfill my second requirement. And he was teaching a physics class the following semester. So I decided to enroll in that physics class, and that was very intimidating at the time. But again, I had a very similar experience and kind of fell in love with physics. And again, at that point, it was kind of a pretty low level, but I'd never been exposed to it before. So that's kind of how my journey into science and space science really started, was through astronomy and then through physics. And then at that point, I actually decided to transfer schools to kind of be able to take advantage of the right opportunities, changed my major to physics, and got involved with some engineering projects. And kind of from there is where my path led to here now as a spacesuit engineer.
Well, it's a great answer, and I hope everybody listening heard that. Tessa didn't like maths. America. This was not a natural thing for you. You didn't enjoy it, and yet you managed to pursue a qualification in physics and go on to work in NASA. And I think, I see that a lot with people coming through the education system. There is often a bit of a fear of math, or I can't do math. So I do think that's fascinating that you didn't originally love math, but you still managed to come into this. Working at NASA, right? We all want to know what's it like. What is it like? What's the best part of working at NASA?
So I think the best part about working at NASA is just being a part of human space exploration and the future discoveries that we're going to make, feeling like I'm really contributing to that exploration and those discoveries is my favorite part. Every day is kind of a different day for me. I get to work on a lot of cool things in the lab, a lot of hands-on things. Sometimes I get to, test the spacesuits myself, and that's pretty fun. So I think just the variety of different things that I get to work on and know that I'm contributing to the bigger mission, which is really exciting to me, that's my favorite part about it.
That's great. And I bet you kill it at Halloween, right? Because you've got any one of those spacesuits.
Yeah, that would be That'd be a very expensive Halloween costume.
Um, so you work in this very specific area with spacesuits and NASA. Are there other areas of science that you're generally curious about, or that really interest you?
Yeah, I mentioned that I kind of first became interested in space and space science through astronomy. So I am definitely still very interested in astronomy, and I, like to keep up with kind of the current research and discoveries. And I still think that that's kind of the most fascinating field. So I think astronomy and astrophysics as well are kind of the areas of science that still continue to fascinate me the most.
Would you want to go into space if it was an option? I can see the ability for civilians to go into space. It's going to come in our generation. Is this something you'd want to do yourself?
I think it is. I've thought about it a lot, and I think I would want to go into space, just to be able to experience. I think a lot of astronauts say that when they return to Earth after being in space, that it really gives them a new perspective on a lot of things, and changes kind of how they see the world. And so I think that would be a really unique opportunity, and I think it would be something I'd want to experience.
Very cool. Yes. I think when you look back upon your career, and you're very early in your career still, but as you look back to your younger self, is there anything that would have surprised your younger self about where you ended up with your career at NASA?
Yeah, definitely. And I think, just having a background in music and theater, I think just my entire career in general, being an engineer studying science would have surprised me. But also, just even more specifically, working for NASA and having a job, my job title as a spacesuit engineer, I would have never even imagined that something like that existed when I was a kid. So just learning about all of these, careers that are out there, these things that people actually get to do. I think I would have been surprised just even having this job title that I do. So yeah, I think that starting in music, it was a pretty big jump, and I think just overall I would have been surprised at where I ended up.
That's great. And do you feel you're in your dream job right now, or is there another job, another dream role that you would love to do at some point?
So I actually really do think that I am in my dream job, at least for the most part. When I was in school and working towards this career, I thought of being a spacesuit engineer as my dream job. And now that I'm here, I don't think that that's changed at all. I genuinely every single day wake up and love going to work and love doing what I do. I think if anything, the only thing that could make this job better and kind of continue to make it a dream job for me is to see the suit that I'm working on currently fly in space and kind of, you know, grow up along with it and live with it for many years to come while astronauts use it on the moon and on Mars. To be able to specifically be working on these suits that are going to Mars, I think that would kind of just be the icing on the cake on top of what I'm doing right now. But I think for the most part, I'm honestly working at my dream job.
I could see that. I think it's phenomenal. And as you say, being able to work on a spacesuit that's going to take somebody to Mars, that's incredibly exciting. Now, Tessa, I'd like to ask you, if there's somebody watching you today and they would love to do what you're doing, do you have any advice on how to go about finding out internship programs or jobs at NASA?
Yes, definitely. So the NASA website in general has a lot of great resources if you poke around on it, but specifically intern.nasa.gov is where you can go to find all of the internship opportunities that NASA has. And there's opportunities for high school students all the way through graduate students, opportunities at every center in every area that NASA has. So, science, physics to engineering, even to business and finance, whatever you're interested in, if you want to do it at NASA, there is an opportunity there for you. So intern.nasa.gov.
I guess for the last question, do you have any advice or suggestions you give to girls who are interested in pursuing a career in STEM?
Yes. So I think right now we are at a very unique time in history where we have the tools, the knowledge, the interest, and the passion to be able to return to the moon and establish more permanent presence. And in order to do this, I really feel that we need people from all backgrounds to be successful. So, for women in particular, we have a very unique experience in our lives, growing up, differences that I think can help us in a team setting be more successful. So the best teams that I've ever worked on have been the most diverse. If you have, a set of people and you're all coming from the same background, you have the same skill set, same life experiences, and you're approaching a problem all in the same way, and that one way doesn't work out to solve the problem, you're not going to have a very high chance of success. So if you can approach that problem with much more different ideas and backgrounds, and come in with different skill sets, and some of those are unique to women, I think that you'll have a much greater chance of success. So I think that if you kind of keep up what you're doing, if you're tuning into this presentation, you're already kind of on the right path. But just take advantage of every opportunity that comes your way, even if it's not something you thought you'd be interested in. It could open up a new passion for you, kind of like it did for me. But at the very least, you'll get some new skills that come along with it that could come in handy in the future. So this is the spacesuit that astronauts currently wear when they do spacewalks or extravehicular activities, which is what we call them at NASA. And on the International Space Station, as you may know, we've had astronauts continuously living in space for the past 20 years. These astronauts have been performing research to advance science and technology, but also help us better understand life on Earth. So why do astronauts need to wear spacesuits when they go outside? Well, the environment of space is pretty harsh, and we are protected by a lot down here on Earth. So first, there are temperature extremes, both extreme cold and extreme heat that can be experienced. Next, our bodies are designed to function here in Earth's atmosphere, not in the vacuum of space. There's radiation, micrometeoroids, and a lack of oxygen that our bodies also require to function, so a spacesuit needs to help us with all of these things. So first I mentioned the extreme temperatures. The temperatures outside the ISS can range from negative 250 degrees to 250 degrees. So spacesuits have multiple layers of fabric and insulation to protect us from those extremes. And in space, there are only two different ways that heat can transfer: conduction and radiation. So the layers of the spacesuit utilize these two methods for thermal control. Astronauts wear what is called the liquid cooling and ventilation garment as well, and this is the first layer that they put on before the rest of the spacesuit, so it sits the closest to their body. And there's over 300 feet of tubing woven into this garment, which we flow cold water through to keep astronauts cool. Next, we have micrometeoroids. Micrometeoroids can range in size from about 50 micrometers to 2 millimeters, which sounds small, but can really do some damage when they're moving upwards of 20,000 miles per hour. So again, spacesuits have special layers designed to protect against these. Next, you probably know that beyond Earth's atmosphere, space is considered a vacuum. So our bodies are designed to function in the pressurized environments of Earth's atmosphere, not the vacuum of space. So in order for our lungs to function properly, the spacesuit needs to provide that pressure to us. So a spacesuit is basically a small one-person spacecraft. And finally, we have radiation. The radiation we have to worry about with astronauts mostly comes from the sun, but some of it comes from deeper in space as well. There are a lot of potential negative health effects from being exposed to too much radiation. And once again, on Earth, the atmosphere protects us from a lot of this radiation. Astronauts do wear dosimeters to track the radiation doses that they're exposed to during EVAs, in addition to being protected by the suit. Spacesuits have been in development for a while now, and the first ones were actually based off of Air Force high altitude pilot suits. And the first spacesuits that NASA specifically developed were for the Mercury program back in the early 1960s. And these suits were only meant to be used inside of a spacecraft, so there were no spacewalks for these guys. And next they made the Gemini suit, which was used for the first EVA in 1965. This suit could be used both inside and outside of a spacecraft. And then finally, we have the Apollo suit, which is the first suit that was designed for doing spacewalks on the moon and designed for doing tasks that required more mobility and moving around a lot. So I will also mention that NASA does still make spacesuits that are for use pretty much only inside of the spacecraft. And these are called the crew survival suits. And these are the orange suits that help astronauts be protected in case there are any emergencies while they're inside of the spacecraft, like the cabin depressurizing. The shuttle ones also had parachutes integrated into them. And so now we are up to the current ISS spacesuit. Because these suits are used in microgravity, they really only have mobility in the upper body. So these suits are called the EMU, or extravehicular mobility units. And these suits provide the protection from all of the dangers I mentioned earlier and enable astronauts to work outside in space for up to 8 hours. These suits were initially designed in 1979, and besides a few upgrades, are still being used today. These suits are modular, so they have a separate upper torso, lower torso, boots, gloves, and helmet, so we can accommodate many different sizes of astronauts. And it's designed to fit the 5th percentile female all the way up to the 95th percentile male. And just to emphasize how much we really rely on the upper body mobility with these suits, there are over 40 different sizes of gloves, but only 2 different sizes of boots. These suits also have a portable life support system, or PLIS, which is the backpack on the back of the suit. And this provides the oxygen and removes carbon dioxide, as well as performing other functions to keep the astronaut alive. So what kind of tasks do astronauts do on a spacewalk? On the ISS, these tasks range from deploying or installing experiments to performing maintenance on the exterior of the ISS. They have toolboxes mounted to the outside of the ISS that they store equipment in, and they have a lot of cool tools, which I won't discuss in detail, but they have special wrenches and drills that are designed specifically for use in space. But pretty much all of their work is done using their hands. So what's next? In the near future, astronauts will be exploring further from Earth. New environments will require more mobility, new tools and vehicles, and even in some cases, autonomous operations. So right now at NASA, we are working on the next generation spacesuit called the XEMU, or Exploration Extravehicular Mobility Unit. This suit is going to have improved mobility designed for walking around and performing tasks on the surface of the moon or Mars. And we also have new gloves to reduce injury. In fact, 47% of EVA injuries have been attributed to the gloves in the past. So we've done some things to try and reduce that. We also are using bearings that are more dust tolerant and boots that will be made to endure rougher terrain. And the astronauts actually put this suit on from the rear hatch, so it's easier to get into than the current suit. The current suit, the EMU, you have to put the pants on first and then the top, so it's a bit more like you would normally be getting dressed, and this one is going to be a bit easier for them to get into. And then there's also the advanced life support technologies as well. In this image on the right, we have a prototype from a few years back of our new suit, and here it's being demonstrated for the NASA administrator, and it's just really cool to see something that we work on go from a concept to reality. On the left here, we have the new XEMU hard upper torso, which is the shirt part of the suit. This is one of our newest prototypes, and the helmet on the suit is also a bit different from the previous suit, the EMU, in that it is designed to provide maximum visibility for the astronauts performing tasks on the surface of the moon. And I will wrap up by talking a little bit more about the portable life support system, since that is the area that I work on specifically. So I mentioned that the portable life support system is the backpack on the back of the suit, and we really fit a lot of components into that small space. So the model you can see on the center of the screen, the red parts are showing what is considered to be part of the portable life support system on the suit. So for the new XEMU, we have oxygen regulators that help us tailor the pressure in the suit to the astronaut's specific destination or environment. We have a new carbon dioxide removal system that can regenerate itself, which is very convenient during a spacewalk. And we have a new heat removal system as well that will cool down the water that flows to that liquid cooling and ventilation garment I showed earlier that keeps the astronauts cool. So finally, if you want to see more pictures of spacesuits, both past and present, as well as videos of our new spacesuit, you can go to the website here, NASA's Suit Up website. Thank you for watching, and I hope to see you all involved as the next generation of explorers as NASA returns to the moon as part of the Artemis program.
Well, Tessa, we've got a few questions. The first one is from Newark Central High School. And their question is it true that people don't age in space?
So that is a great question. And the concept of aging actually depends on the theory of relativity. You may or may not have heard of this, but it's the idea that Albert Einstein first came up with. And it basically says that when you are moving through space, that changes the flow of time. So it's not necessarily that time is moving faster or slower elsewhere in space, just that relative to us here on Earth, people elsewhere in space would be experiencing time differently. So I would encourage you to talk to your physics teacher about this if you are interested in a more in-depth explanation. But when it really comes down to it, people still age in space, just it could be at a different rate relative to us here on Earth. So astronauts on the International Space Station do age slower than us, but only by a fraction of a second, even when they're on a really long 6-month or year-long mission.
And I think you've probably got to balance it with some of the stresses of the job, some of the radiation in space, some of the things that you talked about in your presentation. I think maybe would cause you to age a little more rapidly in space.
Yeah, some of it would definitely even out.
Okay, the second question we've got, and it's kind of an interesting one. Do you think that Mars will be a tourist destination by 2027?
So I think that would be awesome if Mars could be a tourist destination by 2027. Personally, I think 2027 is cutting it quite close. There are still a few pieces of technology that we have to work on and we have to demonstrate fully before we can make that a reality. I think that some of the private companies, Elon Musk and SpaceX, are really making strides towards the large reusable spacecraft that we would need to be able to do this. But given the right resources and with the rate that the private space industry is advancing, I definitely see it happening within the next few decades for sure. But by 2027, that would be really cool. I think that's a little bit optimistic.
Yeah, I mean, I think people forget that little rover traveled 290 million miles
Yeah.
to get to Mars. It's a long, long way away. What do you think about the moon, which is much closer, becoming a tourist destination?
I think that one is definitely more possible in a sooner time frame. I also think that part of NASA's plans for going to Mars include kind of making a lunar outpost, so a station of sorts on the moon where astronauts can stop first on their way to Mars to stock up in resources and really prepare for that longer journey to Mars. So I think in conjunction with that and with our plans to make the moon a more permanent destination for more permanent habitation, I think that the moon becoming a tourist destination is definitely in the closer future.
Yes, I think so too. And the next question we've got is from Weequahic High School, and they would like to know, is there anything that you can be doing while you're going through high school to really prepare yourself more for a career in STEM or a career at NASA?
Yeah, so I think that if you are interested in STEM and you're seeking out opportunities and classes in STEM fields, you're kind of already on the correct path. When I was in high school, I actually was not interested in STEM and I was more interested in music and the arts. So I say that just so that you know that if you don't know for sure where your passion lies, or if you're not sure you want to go into a STEM field, to not worry about it too much. And no matter what you do, as long as you're taking advantage of opportunities that come your way, you will be well prepared for whatever career you may choose. But specifically, if you're interested in STEM and you want a career at NASA, there are NASA internships available for high school students. So I would look into some of those. And you don't necessarily need any prior experience in STEM or previous internships to get those. And then further than that, if your school has anything like a rocket club or an engineering club, I would look into those. And I think that would be a really great preparation for a career in any STEM field or a career at NASA.
Yes, very, very good. The next question we've got is from Barringer High School, and they would like to know what the suits are made of.
So the spacesuits are made out of a lot of different materials, and the outside layers that you see, the white cloth outer layers, those are a special, really strong fabric called orthofabric, and that is made specifically to protect the astronauts against particles or micrometeoroids that they might encounter when they're outside on a spacewalk. But internal to the suit, we have a lot of different materials as well. So the hard parts of the suit are plastic and metal, and really we just have a lot of different materials in the suits that serve different purposes.
And the follow-up question from Barringer High School is, how do you determine what material to use?
So we do a lot of research and testing to determine what materials to use. So we typically start with what is the problem or what is the function that we need this specific part of the spacesuit to perform. So say, for example, the layer of the suit that has to hold in pressure. So the layer of this suit is called the bladder. And we want a layer that will be really strong and resistant to ripping or being punctured, but it also needs to be somewhat flexible for when we're pressurizing or depressurizing the suit and to make sure that the astronaut can still move around in it. So then we look for materials with those properties, do a lot of strength testing and cycle testing, which is basically like if we put this material through 5,000 times of simulating an astronaut moving their arm around, will it hold up? And then based on the results of all those tests, we kind of down select and pick the one that performs the best and meets all of our requirements. And in the case of the bladder that I was just describing, that's kind of a rubbery feeling nylon. So yeah, a lot of research and testing.
Yeah, it sounds a lot of work. And a follow-up question from Barringer High School, and I think it's a pretty clever question, is, are these suits expensive to make?
Yes, spacesuits are very expensive to make. So besides having to meet very strict requirements that takes a lot of time to perfect, we're not quite at the point yet where we can buy spacesuits in bulk. So maybe you've noticed, with other items, if you buy something in bulk, it tends to be cheaper per item. So we're not at that point yet, and that really drives up the price. So the cost to develop a suit, at least all of the ones that we've developed so far, even going back to the Apollo suits, if you adjust for inflation, the cost is in the hundreds of millions of dollars range. And that doesn't account just for materials. Obviously, that accounts for the labor, the people working on the suits, but it's still really expensive. And I think nowadays, if you were to just buy an existing suit, if you wanted to just kind of order one like from a catalog of sorts, or in the future, maybe, when spacewalks on the moon are a more of a daily occurrence, they're still probably about a few $1 million each.
Wow. Yeah, I mean, I figured it would be. It's a pretty exhaustive process that you guys go through to create those. And it's one of those things where they can't fail. They
Exactly.
have to work.
Yep.
So very good. And the last question we've got from Barringer High School, which I think is a great one. Why work for NASA?
So the reason why I love working for NASA is because I get to contribute directly to human space exploration, which I think is really cool and exciting. I love that every day my tasks change, and some days I get to take on more of a project management role. Some days I get to be in the lab testing or actually get in the spacesuit and test hardware to make sure that it's going to work for our future astronauts. So really just knowing that I get to work on the new suit that will enable future exploration of the moon and Mars, which is unique to NASA right now. We're really the only ones working on EVA suits to that extent. I think it's really exciting, and that's why I love my job.
That's great. It's a great answer. I think anybody watching this, I think you take a look at the internships at NASA. I think, Tessa, really thank you for spending all this time with us and sharing with us your journey to NASA and what you do at NASA. I think closing out, I'd just like to maybe talk a bit about the Artemis Pledge. And this is something that it's coming up fast. So we'd encourage anyone who's interested in doing this, and we hope you all are interested. It's something you need to look at quite quickly. Tessa, could you walk us through the Artemis Pledge?
Yeah, so NASA is turning the page to a new chapter of human space exploration. We are going to land the first woman and the next man on the moon, and we need you to help us with a pledge of the Artemis generation to explore. So you can send NASA a recorded video pledge, and we will then send it to the moon aboard the Artemis 1 mission, which is NASA's first test flight of its systems integration of the new space launch system. So if you want to contribute to the next era of human space exploration, you can submit your video via email by April 2nd.
You heard it right. NASA is going to send you to the moon aboard Artemis 1. Well, thank you so much for your time today, Tessa. It's been a real pleasure talking with you and seeing your presentation on spacesuit engineering.
Thank you for having me. I had a lot of fun.